Today's webinar, Making the Case for the IBM Cloud, is sponsored by ATS Group. Our featured speakers today are Bill Osmus, John Byers, and Bob Bender. As VP of Sales, Bill leads the ATS sales team as a recognized thought leader, focusing on the client experience delivered through their products and solutions. John is the Director of Managed Services at the ATS Group, the leading IBM regional integrator in the Northeast. One part engineer, one part sales, and one part spreadsheet creator, and all parts Pittsburgh native. As Director of Support for ATS Galileo, Bob heads up the support and technical pre-sales teams. He has a wide range of expertise in IT, and there isn't a person out there who has a better pulse on customer needs. And so without further ado, Bill, I'll turn the presentation over to you.
Thank you, Janine, and thank you everyone for taking the time out of your day to join us. We will go through a real unique situation, we believe, in terms of these webinars where we're going to actually go through a live customer use case using customer data, showing how we go through our process, proven over years of being in this business, and hopefully at the end you'll see some really compelling reasons for you to look at, using IBM Power Cloud or Power Cloud in general, and then hopefully using ATS to help you get there. So from an agenda standpoint, we'll go through this case study. This is an actual customer of ours, Alpha Broder. We'll go through a demo of how we've gotten to collect their data, analyze their data, a demo on a specific portion of our Galileo Performance Explorer called Compass, which will then actually show you the results, and then we will do a side-by-side comparison. And these are real numbers. These are not, numbers that we've pulled out of any one place. It's actual numbers that we use with this particular client, both from an on-prem standpoint, and then obviously showing you a great deal of benefit to move your power into the cloud. Just briefly, a little bit about us. We've been in the business now for 20 years, built our business really on a consultant basis. We have over 70 engineers. Our experience levels range from every system you could possibly think of. A large majority of our engineers are ex-customers that have been in similar situations from our audience that's participating today. So we offer not just cloud, but also infrastructure services, whether that's on-prem or cloud. Cloud computing, keys there to help you get there. You'll see through our methodology, there's a really very precise, proven, customer-proven methodology to get there. Help you manage it. We know today, especially with what we've all been living through globally with the pandemic, that resources are very difficult to garner. We offer a full range of managed services. We'll help you from a business resiliency standpoint, whether that's doing some kind of business continuance, data protection and recovery, and then a real key piece of data, which is really the currency of today, is the reuse of that data and how that can help create better business results for our clients and the participants on the phone. And finally, the infrastructure intelligence and analytics, which is really going to be the heart of a lot of what we show you today around our Galileo product. Next slide. We have just a variety of things that we've managed, but really what I want to point out here is really the key steps for us in terms of any client engagement. And at the end of this, it's all about the customer realizing the benefits that we help them get to, which is plan it, build it, manage it, analyze it, and then finally report it. It's very key that it's not a one-time process. We want to keep engaged with the client to make sure that that investment that you've made in cloud, it continues to pay off. So without any other further ado, I will turn this over to my colleague, John Byers.
Hey there, everyone. My name is John Byers. I'm Director of Managed Services here at ATS. And today we want to tell you a story here, a story about how ATS was asked by one of our customers, Alpha Broder, to decide if placing part of their disaster recovery power environment in the IBM cloud would be a more cost-effective option for them than, say, versus going down the normal server refresh route. Now, ATS wanted to perform this comparison exercise agnostically without any assumptions as to which option would be the best choice. You can kind of think of it as like the show Mythbusters, where we punched holes through all the preconceived notions about getting into a cloud. So, say this, our time is limited today, and this webinar is a condensed look at what we examined, measured, and discovered. And we actually wrote a 20-page white paper on this entire experience, which tells the whole detailed story. And we'd be happy to share that with you at the end if you ask. So in our evaluation, we aimed to answer the following questions. First, what is the real cost comparison between refreshing a customer's Power Cloud environment on-prem versus the IBM Cloud? We're going to show you our methodology and how we calculated those numbers. Second, can we take advantage of the IBM Cloud and reduce our customers' current on-prem footprint? We're going to show you how we resized Alpha Broder's environment for the IBM Cloud. Third, will they get the same performance in the IBM Cloud as they would on-prem? And to kind of answer this question, ATS did and still does have actually a POC environment running in the Power Cloud, taking a look at those statistics. And lastly, what is our impression of the IBM Cloud? You know, for our POC, we went in there hot, we didn't know what to expect, and we sort of have some thoughts around that. All right, so first of all, I want to do a quick shout out to the folks at Alpha Broder. It was very cool of them to allow us to use their corporate name and their environment for our study. Very good people over there. A little bit about them, so a little shout out, and who they are and what ATS does for them. Alpha Broder is North America's largest distributor of trade, private label, and retail apparel brands. What that means, if you have a golf shirt or a coffee mug or a golf ball with a corporate logo on it, most likely it was procured and distributed through Alpha Broder. Now, ATS itself has worked in the Alpha Broder IT environment for about 15 years, and right now, ATS does MSP services around AIX. We do their IBM storage store-wise. We also run their IBM Spectrum Protect services. We know their environment very well, and we think we're well suited to do this study. Oh, look at that one. All right. So let's talk a little bit about the environment, what we're dealing with here. The Alpha Broder current environment, what we had to study here, the disaster recovery setup consists of 9 servers around the United States and Canada, ranging from Fresno there on the west coast to Harrisburg, where I actually live, in the east, our Canadian friends up north in Richmond Hill, and the southernmost point down there in Orlando, Florida. Of those 9 environments, there's a mixture of 4 Power 7s, and 5 Power 8s. The setup is pretty simple. These are all warehouses you're looking at the map. We have a production and a disaster recovery server at each of the locations you see on the map. There's application replication occurring between the production and application servers at the various sites. And in each of these servers, both as a production and the DR single instance non-virtualized servers. This is a very simple setup. So this is going to be a very simple test for the cloud. It's actually pretty cool that way. So this is an old school way of doing things, but in effect it works for what they need now, but they're just curious about taking it to the next level and heading into the cloud possibly. All right, the comparison requirements. What are we going to compare between what? The goal given to ATS by Alpha Broder was pretty straightforward. You take the 9 existing disaster recovery environments, provide a financial cost for either refreshing on-prem with Power 9, 914 models versus the cost of using the IBM Power Cloud. We're also aware that Alpha Broder is looking to lease this new equipment, and this simplifies things because this turns our comparison to an OpEx versus OpEx competition. Basically, a 3-year monthly payment versus a cloud monthly payment. So of course, over here in the red corner, we have the traditional refresh scenario with these components. 9 Power 9 914s in each of the 9 sites, Each has 4 cores, each has 32 gig of memory, and each needs 500 gig of space. Now the Power 9 is, as probably most of us know, since this is an IBM call, is the smallest Power 9 you can purchase. And this becomes important later because when you see how we size for the cloud, you'll see that there's some wasted resources that you would have to purchase in this environment. Now for our costs, we'll be, of course, leasing this over 36 months. In the blue corner on the right there, we have the IBM Power Cloud. We'll be sizing each site for its individual performance requirements using our soon-to-be-talked-about ATS Galileo tool. We'll also base the numbers off of 36 months, just like the lease, just to be a fair comparison. IBM pricing for cores, memory, disk, and the OS licensing have been injected into our tools so we can see the price and exactly what it's going to look like. So let's compare. And I do want to say this point right now. This isn't here to show any sort of IBM on IBM prime situation here. There's no winner, and there's going to be a winner and a loser. But IBM has publicly endorsed a hybrid solution where some IBM power stays on-prem, some lives in the cloud. It's now their go-to model. So in the end, the winner is IBM, either way you look at it. All right, let's look at how we refresh the current environment. So for the first part of our cost analysis, we need to find, of course, the cost of refreshing disaster recovery hardware in 9 sites. Now, ATS works with Broder, and we do what everybody does in this situation. First, we come up with a satisfactory configuration, pretty simple. Second, we use IBM's Partner World site to access IBM's eConfig, just like we all do, and design a power solution. Once the configuration is complete, we do the 3-year 24/7 cost. And to be fair, we add a 5% discount to list price because if you're a VAR selling this solution, you always get a little bit of a discount off a list, at least for the most part you do. It is the small end server, so it's not going to be a very high discount in this. Next, we add the leasing numbers, basically the cost of money. And when you add it all up for the 9 servers, you have a CapEx, not counting leasing costs, of about $170,000 over 3 years, and about $190,000 when you add in the leasing costs, a little give or take. So their monthly leasing price for 36, $5,328 a month. That's what it would cost to refresh all 9 servers at Alpha Broder. That's the number in the blue corner. That's the number that we need to beat. And that's how we're going to show you from there how Galileo hopefully helps beat that number. So we keep saying Galileo, Galileo, Galileo. What is it? So before we jump into our live demo on how ATS right-sized Broder for the IBM Cloud, I do want to tell you a little bit about the tool we'll be using. It's an ATS home-built tool called Galileo. It's created about 15 years ago, and Galileo was originally designed to be an in-house tool to help our own ATS, AIX, and storage engineers dissect performance issues when we went into our own customer environments. A couple years, but we realized we had a tool that nobody else had and decided to expand on that. We brought in a bunch of developers, kept building more and more features into it, and productized it as a SaaS offering. Galileo has matured over the years into a suite of products, and for our sizing exercise, we're going to be using 2 out of those products you see. First, number 1 there, Performance Explorer, which is a performance tool that gives you visibility across your entire environment. It's built-in deep analytics, which shows you both current and past performance data. We're also going to be using number 2 there, Cloud Compass. Cloud Compass takes that data from Performance Explorer, ingests it, uses pre-built metrics and pricing lists that can be updated daily. Those updated pricing lists will show you your daily spend on what it would be cost in the cloud once it's right-sided. And with that, we want to go to our demo, show you how we did this. Now, I want to introduce our Galileo lead, Bob Bender. Bob, you're up.
And let me turn on screen share. And here we go. And yeah, so really appreciate that. It is a great story. And it all starts with the data. And Galileo Performance Explorer, as John mentioned, goes back to 2007, June of 2007, as a matter of fact. I know that because we have the original data points from June of 2007, and that is huge. Not that you would go back and look at 2007, but the fact that we keep and maintain original data points forever. The other thing I want to touch on is John had the red corner and the blue corner, and here is an example of Enterprise Dashboard where we're showing assets from both on-prem, out in the cloud, wherever they are. It doesn't matter to us. They can be in different data centers all over the world, and we're able to show that in a simplified, easy-to-use, single pane of glass dashboard. So Galileo Performance Explorer has simplified the process of collecting that data. So if you're looking to move to the cloud or you're looking at new hardware, going through that 3-year refresh, this is where you want to start, is having accurate data. So here we see a dashboard. This is actually Alpha Broder's dashboard. And I'm just going to highlight a couple things as we start to head into the data and how we went about sizing their environment. But basically, Enterprise Dashboard is like the asset database for everything monitored by Galileo. And what I'm showing you is out of the box. So we start capturing data, you get access to this dashboard and many others, which I'll touch on. And notice all of the config data down here tells you everything you want to know about each of these assets, whatever they are. And you can even see the processor types here and a breakdown of that. And these tables are actually pretty powerful. You can do a lot in these tables. They're very performant. You can have thousands and thousands of rows in here and customize these tables to be exactly what you want. All of the configuration, capacity, and performance data is available at your fingertips in these tables and in Galileo Performance Explorer. So let's talk a little bit about why we're doing what we're doing. So we created this for ourselves, and AIX happened to be our first agent to market, and so there's an awful lot of depth in around AIX and Power Systems. And by the way, Galileo Performance Explorer supports anything that runs on power, as well as many other things, storage, SAN, and so forth. But you'll notice that in analytics, that's the dashboard that you're seeing here, these are rules based on subject matter expertise and experience around the technologies that we're talking about. So in this case, AIX, we have things like shared pool utilization over 80%, or capped entitlement, greater than the number of VPs, large pages allocated, but not being used. That's possible waste. So these are things that are very specific to an AIX environment, to someone that's working with AIX on a daily basis. We also have possible misconfiguration reports. This is some of the intelligence, the depth that you're seeing built into the tool from our subject matter expertise. Capped entitlement less than VPs we just touched on. Go out and audit the environment and check all of my diffs for Q depth settings against a Q depth setting of 32 or whatever you want it to be. You can customize these reports, make them what you want them to be, and even audit your environment against config changes across the entire environment. So here's an example where we can run a configuration change report, go out and tell me everything that changed in this environment over the current year. We can update this. And just to illustrate how powerful this is, you'll actually see here in a couple seconds where it's auditing the entire environment since January 1st for a number of LPARs, quite a few LPARs, and giving us a summary of when changes occurred, where VPs were added, where memory was added, things like that. And there it is. So we just audited an entire environment for 2,500 LPARs in this case, and came back with a summary report of when these changes actually occurred. And then all the details are presented here too, if you wanted to dig into it. Very, very powerful tool at your fingertips. One thing I want to touch on, since we're talking about assets moving to IBM's Power Cloud and disaster recovery, this is actually a report that comes with Galileo Performance Explorer. It's part of the Galileo Report Studio, but it answers a question. It's a single page report. A couple of our customers are getting this around their power systems. And the idea here is that it actually presents normalized data broken out by tiers, pulled in from CMDB data, and shows do they have the capacity, their DR, or with their DR assets, to absorb their production assets based on tier. A single page report goes out the first of every month, and it's in the inbox, and it tells them exactly what they have in capacity. It also trends it out. The production performance trends out over 6 months, and you can see a reference line in here as to the capacity at the DR. These little arrows here are highlighting a trend based on, from this report run, checking and comparing against the previous 30 days. So we see, are we trending up, trending down, and broken out by tier. Custom data ingested and attached to the assets within Galileo. Very powerful. And now let's get into what exactly is the data that we're collecting. So we capture 1-minute samples and everything you need to know about an individual LPAR or a physical frame. If you have physical frames on-prem, which I'm going to assume most of you do. And we do something here, I'm going to just touch on this real quick around virtual fiber channel adapters and physical adapters and NPIV, because you'll notice the way that we present this data is VIO server, colon, the physical adapter, colon, the client LPAR, and its virtual adapter. So we can see exactly what's going on from a physical layer and a virtual layer. This is shown to you now because it's a very powerful story in why we're presenting data a certain way. Anybody can put a chart together. We're putting this data together in an intelligent way that makes sense for someone working with these systems. Okay, so Alpha Broder. As John mentioned, they have 9 different systems across the country, across the United States. And we're looking at one of those instances right now, and it's in Chicago. And I'm going to start walking through some of the individual metrics here. We're getting a little bit deeper into the data. So you can see here in my favorites dashboard, in the Explorer view, this Explorer dashboard, again, out of the box, you'll see I have logical CPU utilization, I have host file system capacity, real memory utilization, network throughput summary, RPerf consumed, which we're going to touch on in a second here, and run queue. Now, these are just some of the metrics I threw up into my favorites dashboard, but if I continue scrolling down, you'll see there's a ton of other information available, including spectrum scale performance charts you'd see shown here if you actually were running in a spectrum scale cluster. Now, this is one of the LPARs. Now, chances are pretty good that we're going to look at multiple LPARs when we're talking about going to the cloud, but it starts with the data. So here, let's focus in on what we want to see here. So I'm going to go down and take a look at CPU first. And you can see VP utilization, CPU entitlement utilization. And we also see, by the way, that this is a dedicated SMT4 partition type in the config data here. It's capped, 4 VPs, 14 gig of memory, everything you want to know about this individual system. But the RPerfs here that we're showing, this is calculated based on the information, IBM's public RPerf rating. We have that information and we do that calculation for you so we can see what the normalized consumed RPerf or relative performance is for this particular LPAR. Now, looking at one LPAR is pretty cool. That's good. And we can look at memory for that one LPAR. But we have 9 total LPARs in this case that we want to consider for a move to the cloud. And we need to size that. So this starts with Tag Manager. Now, Galileo's Tag Manager gives us the ability to tag and group assets together in meaningful ways, like take my 9 LPARs and put them together because I need to size that for some exercise. Now, I'm going to show you that there's actually a couple things about Tag Manager. First of all, we give you tags out of the box, just like many other things. So, for instance, if I wanted to come in and say, show me all of the AIX6 operating systems in this environment. Well, here it is, out of the box. Show me all of the AIX6 LPARs. Or I want to go look at maybe all of the LPARs that are running SMT4 shared. We can do that as well. These are tags out of the box. But in our case, we actually want to create something that's new because we're very interested in a specific set of LPARs. So we can go in the tag manager and select the assets that we want to group together. Now, that's a static tag that I'm talking about. You could dynamically tag as well. You might have a naming convention that says everything named Harrisburg, as an example, is going to be tagged automatically. So that way, if you add new assets, spin up new things in the cloud, wherever they are, they're automatically included in that group. So in our case, we have a tag that's called Power Cloud 2020 Production. And here you can actually see what that looks like. And we show the top 10 by default, and we show the last 24 hours by default. But because we never purge data and we never roll it up, you can always go back in time and get original data points. So it's important to note that, because we're going to go back and look at the last 30 days when we start talking about sizing this, so we have an understanding of over the past 30 days what the peaks look like in that time frame. So, but looking at this right here, we see network throughput, RPerf consumed, and we see we're looking at the top 10. So what I want to do, you can see here, this is all 9, and then top 10 of 18 network throughput. This is actually giving you send and receive in a single view. So what I want to do is I want to go back here and say, show me the past 30 days across all 9 of these LPARs. So I'm going to update the chart. Just this chart. We could update the whole page, but I'm just going to update this one chart and get an idea of what that looks like. We'll double click and just highlight that period of time. And you can see that the stack is 130 total RPerfs over that period of time across the 30 days, across all 9 LPARs stacked together. These are the ones that we've selected, that we've chosen to analyze for our exercise here. Now, that introduces us to Cloud Compass. In fact, actually, before I get too far into that, let me also touch on memory. The same thing applies to memory, to network, to disk. Anything you want to see across the entire tag, you're going to be able to see because we've combined it all together. So Cloud Compass takes all of that and puts it together and gives you some intelligence around that information. So Alpha Broder, we're going to select our site. This is going out and getting the site that I have access to in Galileo Performance Explorer. And we're going to select the tag that we have out there called 2020 Production here. And we're going to run this report. So this is going out right now against IBM Power Cloud pricing that we pull in daily and analyzing exactly what the lift and shift cost looks like moving to the cloud for each instance that you see here. So starting off with Fresno, Chicago, and so forth for the 9 LPARs. And you'll notice we can select any of the assets that we want to select here. You've also noticed that we're looking at the last 30 days. We can, again, do whatever we want here. But this is going to give us a good indication as to what we should be spending if we were to just take a lift and shift, take our work, our systems, and move them out to the cloud as configured and see what that costs. But you'll notice something more important here, because Galileo Cloud Compass does more than that. Galileo Cloud Compass will right-size your environment and tell you where you could actually realize some savings. And I'm going to dig into some of the details around that. You'll notice here the operating system, your peak RPerf consumed. This is the CPU, the right size, and then you can see the right size is 1.5 and 3.25 and so forth down the line. This is based on the peaks over the last 30 days plus 20%, the lift and shift memory, and all of the details that you'd want to know about each one of these instances. Now, if you want to go a little bit deeper, you'll notice the actions over to the right here. This kind of gives you a quick look at this individual instance. So Fresno, we can see, we get an idea in the little charts here, peak CPU, 43%, memory, and so forth. But down here, we actually highlight the lift and shift and the right size configuration. And this is true of all of the individual LPARs that we're looking at here. So all of the details are there. And let's sort these columns a little bit differently and go off and take a look at one of these guys. So I want to pull up one of these LPARs and take a look, because I see $410 in savings per month that Galileo Cloud Compass is telling us is out there. So if we go over to Galileo Performance Explorer, which, by the way, is just clicking on this little home button, all seamlessly integrated, you'll see that we have very little CPU activity. You can see the RPERFs consumed here in single digits, but I'm kind of curious about this. I'm looking at the last 24 in this case. Let's go back 30 days and see, is there a peak over that period of time? Cloud Compass says there wasn't, and there you can see very little activity, 16 logical processors here. Let's go back even further. Galileo has the original data points and all of that data kept forever. So we can go back and see, well, our peak was 1.14%, 4.87% over that period of time back in March. That's not enough necessarily for us to maintain that configuration. So when you look at this board, what Cloud Compass is telling us, you can see total savings of $410 is very much real information, real data. So what I just walked you through, that exercise of determining what we have in the way of capacity across a number of LPARs and what's being consumed, this is an exercise that many of you have been through, and I know we've certainly been through on our, and I know personally I've been through for the last 20 years, right? Spending hours going through and finding the data first, and then applying it here, which, by the way, if you have NMON data out there, Topaz NMON data, that's something we can seamlessly ingest in the Galileo. This is something we've spent so much time on. Now we don't have to. We literally have this available to us at our fingertips. We have the data collected here, 1-minute samples kept forever. Cloud Compass is able to analyze that data, determine what a lift and shift looks like, and what a right size, what that should look like, as how we can realize some savings there. And in this case, there's $2,700, almost $2,800 in savings per month, in addition to just moving to the cloud. John?
All right. So a question came in, Bob, when you were doing your presentation. I answered it in the box there, but I do want to tell the whole crew this. That the question was simply, does this run for IBM I? And the answer is yes. We would measure CPW instead of RPERF. It would run exactly the same as you saw on the screen there. It just so happens that our client in this situation runs AIX. If they were running iSeries, we'd be doing the exact same thing, only taking a CPW metric. So just I thought that was an important point to put out there. All right. So what do we just see here in the demonstration? So straight up, when correct sizing comes into play and we're strictly looking at costs, the IBM Cloud obviously wins this. You know, after tallying up after ATS Galileo tool right size of the environment, final tally shows $5,328 for the physical servers, $2,782 after it's been right sized. 45% savings that our Galileo tool sees that our customers, Alpha Broder or you, can obtain here. But we need to make a point here. This is only the case because it was correctly right-sized. We need to be perfectly clear. From this analysis, we are not saying, again, we're trying to be agnostic and look at this as from an honest perspective. This does not say that the cloud itself comes out less expensive going head-to-head on CPU, memory, disk, and licensing versus an on-prem solution. The math actually shows in this scenario, and we've run the math, by not right-sizing. And if you don't right-size your environment, that whole cost of it gets very close. The on-prem solution, if you remember, was $5,328. A non-right-size cloud solution for the exact same specs, the 4 CPU, the 16 gig of memory, the disk, is actually $5,804. So the key to cloud savings, and I can't stress this enough, is right-sizing your environment. Okay, so before we go on this slide, a little game here. That's an iconic picture you see in the background there. Everybody knows who the guy is standing up. Who's the guy laying on the ground there on the mat? First person who answers in the question bar with your name and your email address, we're going to send you a $10 Starbucks gift card. So take a look. Who's the guy laying on the mat as we move on? Answer the question, $10 from Starbucks. So from here, I do want to touch a little bit more on that Performance Explorer and that Compass right size tool we just saw there. It not only works for the IBM Power Cloud, it works for any cloud. We can right size environments just like you saw in IBM, both their Power and their Intel clouds, Amazon AWS. It works in a GCP, which is the Google Cloud. It runs in our own ATS cloud we have on-prem here. And now we can even size, as of a few days ago, Microsoft Azure. And a shameless plug here on the 17th, our very own Bob Bender, who you just heard speak there, will be doing his own webinar showing how you can right size in Azure if you happen to be looking at that cloud. So 17th, if you're interested, let us know. So I want to jump back here, back to IBM. This Galileo tool also works fantastic in a whole different scenario here. And it's the other half of the IBM hybrid scenario, and that's the on-prem solution. It's how I personally used to first use this tool a couple of years ago, actually. There's no more guessing anymore. So if you're on-prem and you want to stay on-prem and you have Power 7 servers and you need to go to Power 9, if you remember the old school way we all used to do this, you had 8 cores on your Power 7. No one really knew exactly what to do, or very few did. That give you an 8-core Power 9. So that's no longer needed because you can run Cloud Compass and Cloud GPE on your existing on-prem server. It does the same metrics. It will show you, hey, on a Power 7, I may need those 8 cores, but on a Power 9, I only need 4 cores. So why would I buy those extra 4? We show you exactly what you need to lower that cloud spend, and we have the math and science behind to prove it. So you know that those software costs against those cores are expensive, and you might not need as much as you think. Try to lower your costs there. So we're down to the 4 things you'll remember here. So in 2013, I believe her name, Carmen Simon, her name was Dr. Carmen Simon from the University of North Carolina, did an exhaustive study on what people remember in PowerPoint. So no matter how much talking we've done today, human brain is only going to allow us to remember 4 things. So the first thing is you're going to remember this slide. It's different. It's human nature. You just will. We want you to remember these other 3. Right sizing is the key to your environment, is the key to cloud savings. Without right sizing, you're going to pay just as much, in some cases more if you go to the cloud. You right size it, it seems like appears you will pay less. And definitely in our example here, we're paying less. Third, the ATS Galileo Cloud Compass, that's the tool that can get you the right size and price your environment quickly and accurately. As fast as Bob was pressing those numbers, you were seeing the different costs priced up daily to see what your environment could cost in any of those clouds we mentioned. And last, ATS, we're a 20-year services organization, mainly around IBM, and we have the expertise to get you to the cloud. So with that, thanks for listening. I'm going to turn this over to Mr. Osmos, who started off the show. He's going to end it.
Again, well, thank you both, John and Bob, for taking us through a very compelling example of effectively getting to these cost benefits. So what we're trying to wrap up here with you guys is really, when you think about moving your workloads to the cloud, there really is a process and a methodology that really takes you from a good customer experience to maybe not so much, right? We've worked with a lot of clients over the years, and the initial wave was, let's get to the cloud, and we'll kind of sort it out from there. And a lot of those experiences ultimately return a negative return on investment. So again, there's a very specific methodology that we use, homegrown tools, and from that experience, we can literally state that we will save you a minimum of 25% as far as moving your workload to cloud. Now that, again, as was pointed out, a lot of that has to do with right sizing, analyzing the data. So we'll get back to what we said up front. First we want to plan it, then we want to build it, we want to manage it, analyze it to continue to make sure you're getting the right experience, make sure you're realizing the savings that you did up front, and then report on it. So
thanks again for joining us. Have a great day and stay well.
Reality check. Infrastructure is not easy. There is no magic. If you were to count up the things needed, it's 24 key skills for servers to do things. Let's take VMware. Launched in 2001, but really didn't become mature until 2005, and really made a big impact on servers. Networking, there's 23 things, and Cisco and others have done a great job here. And finally, storage. It's the core to all your data. It takes over 74 unique skills. IBM has made a significant impact here with storage virtualization, with features such as compression, placement of data, and tiering. They basically have taken out a high percentage of those 74 things. At ATS, we are very good at these three skill areas. Another reality is data's on the move, so let's talk cloud. Statistically, 20% of the data has already moved, but it's the easy stuff. Things like email, file, backups. The 80% left is core to your business. It's vital. It makes you money. Those that do it right outperform their competitors 7x. Do it wrong, you're likely to get beat. Let me tell you about our journey to the cloud. It's not easy. We recently deployed a SaaS offering of our own to the cloud, and the skills we learned are invaluable. Skills are that critical.